This is the example number 3, section 12.7. The train engine has a speed of 20 meters over second and the acceleration of 14 meters over second square acting in the direction shown. So we have a train that it goes to a curved path, and then we have the acceleration that makes 75 degrees from the tangential path, tangential direction, so we call that tangential direction of the curved path that the train is going. And then if this is the tangential, we have a normal direction that goes inside the curve towards the center of the radius of that curve. So we have the tangential and the normal, and we describe those directions with a unit vector, tangential vector, and normal vector. And we want to find the rate of increase of speed and the radius of curvature of the path. For the solution, we need to remember that when we have a curved path, our acceleration has two components. Have a component in the tangential direction, right? And has a component in the normal direction. How much is the component in the tangential direction? We know that the tangential direction is the derivative of the velocity in the tangential direction, right? So we'll be in the vector form. How much is the normal? Will be the velocity squared over radius of curvature. Magnitude, we have to say that the tangential is just the velocity and the normal acceleration is just the velocity squared over radius, right? So we want to find the rate of increase of speed. The rate of increase of speed is just this expression right here. So, and we are given the magnitude and the direction of the acceleration. What we do is decompose our acceleration. Let me go to another color. So we decompose the acceleration in the tangent acceleration and the normal acceleration. Our tangent acceleration will be the acceleration given cosine of 75. And the normal acceleration will be the sine of 75. Acceleration is 14. We can say this is 14 times cosine of 75. And this is cosine of sine of 7. We know that the rate of change of speed will be a cosine of 14. Let me write already 14 cosine of 75. So you get your calculators, and how much is that? 3.623 meters over second square. So to get the next questions, radius of curvature of the path, we will use the normal acceleration. So the normal acceleration, we know that is velocity squared over rho, right? And we know that the normal is 14 sine of 75 equals to the velocity, which is given 20 squared over the radius of curvature. That is the variable that we are looking for. So we solve for the radius, and we got that is 20 squared over 14 sine 75. So if you get those the calculators, you can calculate that the radius of curvature is 29.6 meters. And that radius is exactly this one that we have here. So those are the results that we were asked to find.